Good day, good day, everyone. It's another beautiful day to check out one or two things in mathematics. And this time around, we're taking a quick look at algebraic process. Okay. Before now, I believe you know what algebra is. A branch of mathematics that algebra is. That's where we learn how to manipulate uh, numbers involving letters. Yes. So it helps us to find variables, to find unknown values as much as possible. So in the course of this study, we're to check out how to perform basic operation involving algebra, be it in whole number form. So basically, we're going to be checking out how to perform operation involving algebra. So the process that we are to take whatever expression or equation we are given through for us to get the desired results depending on what is demanded from us. Okay? You should be able to simplify algebraic expressions, factorize linear and quadratic expressions, expand algebraic expressions, and simplify algebraic fractions. And lastly, you should be able to find value or values that make an algebraic fraction undefined or zero. Find a value that make an algebraic fraction undefined or zero. We'll be checking out an example. So we're starting off with a simplification. We have to simplify each of the following expressions. Looking at it very well, you call it easy peasy. You have minus x minus 2y minus 3x plus 5y. Okay, so if you're given this and you are to simplify, the first thing you do is to collect like terms. So I'm collecting like terms means the one that have similar term. Looking at this, you can see we have minus x here, we have minus x here, we have a y, and we have y here. Okay, so looking at it as it were, we can say or simply bring it together this way. You can see minus x is beside minus 3x, and the rest follow in that order. So from what you have there, or if you simplify further, you have this as your final answer. Please don't at any time say minus 4 plus 3. It will not give you xy. That is very, very wrong. Yes, you shouldn't try that. Okay, so that being said, let's take a look at the second question. There's a little difference in the question in that if you look at it very well, if care is not taken, you will think there's no like terms there. 3.2 dg square f minus 4.2 feg square plus 2.5 dfg square minus efg square. Now, when you have something like this, you have to be very careful. At times, they both might not be in the same order, but if you check very well, they have like terms, meaning that they don't have more or less of any of the variable than the other. For instance, we have d here, we have d here. We have f here, we have f there. We have g square here, we have g square here. So that makes this and this like terms. Okay, so in some cases they might decide to confuse you by not arranging them the same way. Even though in the course of your solving, you should arrange them the same way. So we're going to collect like terms now briefly. So we're collecting our like terms. It's obvious. We are bringing 3.2 dg square f together with a 2.5 dfg square, which we can just simply add together. And the same thing goes for the other one. We have 4.2 minus 4.2 feg square and minus efg square. Okay, so from what you have there, of course, when you're bringing them together, it's very important. It's expected of you to rearrange them to now look alike. You can see we did not add anything to them, we did not remove anything from them. They are still the same thing. So you can treat them as like terms. So the same way we solved the first question, that we added those in x together and those in y together. So the same thing we're going to do here. We add those in dfg square together and those in efg square together. So 3.2 plus 2.5, of course, that will give us 5.7 dfg square. And the same thing goes for the second value here, minus 4.2 efg square minus efg square. Okay, so everything will give us, that's a 5.2 efg square, which if you look at very well, you check, you don't leave your answer until there is nothing else to be done. Okay, if you stop when there is still something to be done, your answer cannot be taken as final. Yeah, so you'll be wrong. Yes. So if you look at this very well, they have common factor, yes, which is fg square and fg square, which we are going to factorize out. So what we simply do is, since we know that fg square is common on both sides, so we bring it out and you use fg square to divide everything. So that will give us, of course, the other one disappear. And you know the good thing about this is, if you expand this, it will give you this back, to give you this back. So that's another way to look at it. All right, that being said, let's take a look at another question. Look at this. We have to simplify minus 12a square b times minus 5ab square divided by minus 10 a raised to the power 4 b square. Okay, this is another easy peasy. Okay, what you have there, what you simply do, you can rewrite it in a form that look more familiar to you. Can you see that? Okay, whereas you can apply law of indices as applicable, but beyond applying the laws of indices, you can actually separate this into its fragment form, in which case we have this minus 12 a square b is the same thing as minus 12 times a times b, and minus 5ab square is the same thing as minus 5 times a times b and times b, all over minus 10 times a times a times a times a, and the b squared there times b times b. Okay, so this is a very simple way to look at it. And what you have here, you agree with me, b cancel b here, b cancel b here too, a cancel a, we have a cancelling a here too, a cancelling a here as well. Okay, so from what you have there, what do? We cancel. simply multiply minus 12 by minus 5, and of course from our denominator we still have minus 10 left. Okay, so that will give us 60 times b over minus 10 times a, which we can still simplify further. If you will agree with me, yeah, if you agree with me, we can simplify further. That's it will give us 6b over minus a, which we can otherwise write as minus 6b over a. So it's going to give us minus 6b over a. Taking a look at the expansion, expand the following expressions. Okay, you have a 3x plus 5 and 7 minus 4x. Whereas you have the second question, 1 over 4x minus 3, then 1 over 2x plus 2. The expansion here is done in such a way that 3x is multiplying everything. Okay? So if 3x is multiplying everything, 5 is also multiplying everything. And how do we go about that? So we sort that by cos 3x multiplying everything as stated there, being outside the bracket, and plus 5. So please be careful. That plus 5 is very, very important. So by that plus 5, we imply that if it is minus 5 that is there, it is going to be minus 5 that will multiply everything. So if you open the bracket, 3 times 3x times 7, that's 21x. 3x times minus 4x, that's minus 12x squared. Because minus times plus will give you minus. So the same thing will happen here. 5 times 7, 35. 5 times minus 4x minus 20. Okay? So from what you have here now, few things you have to do. If by reason of your expansion, like times has not been collected, you have to ensure you collect the like times. Another thing is, for the sake of proper arrangement of the expression, your expression is either meant to be in the ascending order of the increasing power of x or decreasing order of the decreasing power of the variable there, which in this case is x. So this is what we're talking about. When you have it this way, the highest power is square. So that means you arrange that squared value. Okay, the squared with the coefficient, you arrange them first, then you follow by reducing it. In this case, highest power is 2. But in some other cases, you might have it as 3, it can be 4. So in any case, you make sure the highest one comes first if you are arranging in descending order. But if it is ascending order, you start with the constant term. I believe you know what constant term is. A constant term is just a number without alphabet. Okay? So it doesn't have any alphabet. So regular number, if it's in your expression, that comes first. And then the lowest power of the variable comes next. Okay? So now that's what we have done here. So we collected like terms and we also rearrange at the same time. And that's what brought minus 20x plus 21x together, which you can simply sort out to get plus x. Okay, so that means your final answer is minus 12x squared plus x plus 35, because there's nothing else to be done on it again. If by any reason, for any reason at all, you discover that something can be factorized out, please go ahead and do that. Or else, you stand a chance of not getting your full mark. Okay, so that being said, let's take a look at the second question. Okay, this is another beautiful question. The same procedure. 1 over 4x is multiplying everything, and minus 3 is multiplying everything too. Okay, so if you're doing it that way, by that, it implies that 1 over 4x times 1 over 2, of course, will give us 1 over 8x squared. Please be careful. When you are multiplying a value, an algebraic expression, with another algebraic expression, number multiplying number, and the alphabet multiply the alphabet. If they are the same alphabet, it means the power increase, of course, according to law of indices. And also, if you list them out one by one, or by implication, you get their respective value. So that is what has happened here. So 1 over 4x times 1 over 2x. So 1 over 4 times 1 over 2. Okay, so that gives you 1 over 8, and x times x, that gives you x squared. So that's how we come about that. So the next one is 1 over 4x times 2. Okay, very simple. That's 1 over 4x multiplied by 2. Multiplied by 2. If you're multiplying it by 2, by implication, it means that, of course, 2 here, 1, 2 here, 2. So that's why you have 1 over 2x. And the next one, minus 3 times 1 over 2x. That's minus 3 times 1 over 2x. Okay? So if you look at it very well, what you simply do is just multiply the minus 3 by that, and by the multiplication, to give you minus 3 over 2x. And that still goes for minus 3 times 2. So minus 3 times 2 will give us minus 6. Okay? So by that, we are sure that we have fully expanded. Yes, we are expanding, but we are not going to stay there, because we have a term in x here and a term in x here. So what do? You do your regular addition. So if you are confused as to what to do, you agree with me that if you take the LCM, that will give you 2. That's what? 2 into 1. That's 1 minus, what do you have there? 3. That's x. Yes, because you are just adding the value. Yes, that means you have what? Minus 2 over 2x. Okay, so which is what we have here. And if you have it in this form, you agree with me that 2 can cancel 2. Yes, so if it cancels 2, we're left with 1 over 8x squared minus x minus 6. So it's as simple as that. Okay, so from what you have there, if you still don't understand, please go over the explanation again. I believe it will make more sense. Okay, we're still taking a look at expansion. But this look a little different, because it combines multiple expansion. Yes, you have to expand not just in one place, you expand at different points. And if you look at this equation, 9 minus 3 into x minus 4, that's bracket close, minus bracket open, x minus y, bracket close. Okay, and then a bigger bracket that cover everything. So this is a form of a nested case. Okay, what I mean by nesting in this regard is the fact that you have bracket inside bracket. So whenever you ask something like that given, what you have to do is to solve the inner bracket first. Okay, so you take a look at it, the inner bracket, which is this and this. So you use this negative to expand this, and you use x to expand this. So let's quickly do that. Okay, so from there, you agree with me. 9 minus 3, x times s give us x squared. Okay, and x times minus 4 give us minus 4x, and minus times x give us minus x, minus times minus y, that's plus y, because minus times minus is plus. Okay, so that being said, we can then progress. You agree with me that we can collect like times? Please, once you can collect like times, go ahead and do it. It's one of the best way to simplify the task before you. Okay, so now that being said, we can of course reduce this into this. So two things you can do: either you collect your like times first, simplify first, or you can just expand. Yes, you can expand, yes, using the 3 outside the bracket. You can see that because we have opened the first set of brackets inside, it leave us, permit us to be able to deal with what is outside the outside bracket. Okay, so from what you have there, if you open this will give you what you have here. That's minus 3 times x squared, giving us 3 minus 3x squared. So minus 3 times minus 4x give us plus 12x, because minus times minus is plus. So the same thing goes for minus 3 times minus x. That will give us plus 3x, and minus 3 times y. That's going to give us minus 3y. Okay, by that, and at this point, we can safely simplify and collect like times, and also rearrange. Don't forget the 9 that is here, we have already thrown it to the other side. So we started, so in this case we still use a descending order in the power of x. Okay, so from what we have here, even though we have y here as well, so assuming we have y square, we will have put y square after the x square, before the one that have x and before the one that have y. So it's very, very important to take note of that arrangement, so that you won't mix anything up. Meanwhile, at this point, you agree with me that we can move on. Meanwhile, one other thing you can do here is you have a 3 going for everything. So you can decide to factorize it out. But I think your answer is best left in this form. Okay? If you have an OBJ question and you have your answer given in another form, just be very, very observant. Okay? That will still give you the same value in another form. So for the B, we have a 5 minus y and a 2y minus 5 minus 4 minus y squared. Okay, so don't forget, all what we have been applying is still part of what we have known in board maths. So for what you have here, when you are given this, of course, you can take care of this bracket, but both can actually be done simultaneously, meaning as you are expanding one, you are expanding the other. Okay, so don't just say, okay, let me just do one first. If that works for you, it's fine, but you can actually be solving them together while you simplify. Okay, so from what you have there, you can see I have started my own here straight up. So the first step here is to show that 4 minus y all squared is the same thing as 4 minus y times 4 minus y as given there. Okay, so on what you have there, you just expand further. If you expand further, you have the resulting expression. Of course, you still keep expanding. Don't forget to, there's a negative outside there. You make a mistake of not considering it. That's why that bracket is there. If it is plus, it will mean not much. Even though it means something, but it won't affect or alter anything. But when it is minus, negative always alter everything. Yes, it alter itself, it alter the positive. So that's what negative does. And in that case, you should be very, very careful with negative. Negative changes everything. Negative changes everything. So when it's outside the bracket, you have to be very, very careful. Okay, so now let's simplify further what we have. Of course, if we rearrange, we simplify this one here, and we simplify what you have here. Of course, 5y plus 10y, that's what give us the 15y here. Okay, and then for this, minus 4y minus 4y, that give us 8y. Okay, so don't forget our negative is here. So we can go ahead and expand it by multiplying through by the negative. I mean multiplying the 16 minus 8y plus y squared by the negative. Okay, so from what you have here, so you can see what I'm talking about. This is a little digression. You can see this is an arrangement in ascending order. Okay, so in some cases it is not bad, it is acceptable. That's for your final answer. But you're better off, I still prefer you use the descending order, especially depending on what is demanded of you. Okay, so from what you have here, you can conveniently collect like terms. So if you're collecting like terms and simplifying further, you agree with me that um, minus 2y squared minus y squared will give you minus 3y squared. Okay, if you do 15y plus 8y, you agree with me to give you 33y. And the last but not the least, minus 21 minus 16 will give you minus 41. Okay, that's just it. It's as simple as that. Okay, so now let's take a look at another part of this topic, in which case we'll be talking about factorization. Factorization. Yeah, factorization involves bringing out factor. In most cases, we can call it common factors. In fact, to make it more uh, simple for us to be able to identify, it's actually the highest common factor that we take out when we factorize. Okay, so we do that to make our work easy. Let's take a look at this question. We are asked to factorize this, meaning that you bring out all necessary factors. So from what you have here, you agree with me. Few ways, two ways we can do this that will help us to properly simplify. One of it is we bring the term in x together with our brother here, or you can decide to bring the term that has x, it also has y, you can bring it with this our friend there. In any case, make sure your rearrangement permits, or you explore, you use the one that look alike together. Yes, don't just assume that there's nothing that can be done, because you won't get your answer or the expected answer if you don't do it that way. So from what you have here, what I simply did here was to rearrange. So if you're rearranging by that, what I have done here is to just, of course, I took the 5y to the 20. Y minus xy goes to the minus 4x. Okay? If we do it the other way around, if you bring minus sy together with 5y and 20 together with minus 4x, you will still arrive at the same answer. Okay? It might just look like something arranged slightly differently, but it's still the same value. Okay? So if they are the same value, we can then do what we call grouping here. Grouping, grouping. Now, grouping. You can see my bracket here. This is not bracket. This is like a broken bracket. Yes, I intentionally use that so that you don't get confused because it's not a bracket. It's just imaginary. The essence of it being there is to regroup. We are just using it to group it. And if you don't group it that way, the grouping is just meant to help you to realize how you are meant to solve it. Because if you don't group it that way, you won't be able to properly factorize out. So you can see, I cage this negative with with the 4x. So because it belongs to it. So when you are factorizing, you have to consider that. Okay. So I already said what we do when we say we factorize is actually taking out the highest common factor. For instance, in 20 and 5y, the highest common factor is 5. You agree with me, right? So what you do is you have 20 plus 5y. Of course, if we say the highest common factor is 5, so you bring the 5 outside. So if you're bringing the 5 outside, 5 in 20, so divided by 20, oh, sorry, divided by 5, divided by 5, and divided by 5. So that will give us what? That's 4, that's 5 into 4 plus y. Okay, so you can see how easy that is. So we'll just simply use that to factorize the first part of this equation, which is this. Okay, so if you're doing that, that means it's what leads us to have this. And if you check the second part, you have minus 4x minus x xy. So in that case, what do you do? Of course, you factorize the common factor. And if you look at it very well, x is common, Abby, but it's also advisable whenever you have a negative outside the first value of the binomial. Okay, what I mean by binomial is a two-term expression that are in the bracket. It's better you use a negative value. In most cases, using that negative value bring clarity and it solves a lot of issue in helping you to factorize properly. Okay, so from what you have here, so this is going to be what? Minus x. So if you're bringing minus x out to factorize, that's minus x, minus 4x over minus x. That means you have a minus xy over minus x. Okay, if you have it this way, what do we do? That means minus divided by minus, that's plus, and s cancel x. Same thing goes here. Minus divided by minus, that's plus, and s cancel x. Let's say 1, x 1. So that means we are left with minus x 4 plus y. That's how we come about this guy here. Okay, that's how I'll come about that. So from what you have there, you can then simplify further. So by simplifying further, we mean that this and this, they are the same. Okay, and once they are the same like that, what you do is you just pick one of them. Okay, before you pick one of them, you bring out 5 minus x, then pick one of them. That's 5 minus x and the 4 plus y. You can see, you pick one of them and then you pick the 5 minus x as stated in that place. Okay, so now let's take a look at this set of questions. It's another beautiful question here. So we'll quickly take a look at this. If you look at it very well, you have 8a x squared minus 12b x cubed. What you are simply doing here is factorizing. Don't forget, I said that whatever number you're using to factorize or whatever value you're using must be the highest common factor, meaning the highest value that can go in the two values, or if it is 3, in all the theories. Okay, so it's very, very important you take note of that. All right, so from what you have here, you agree with me. Okay, the highest common factor here is 4x squared. Don't forget what I said. What we have simply done is we brought 4x squared out and we divide it by 4x squared. And then you have your 4x squared here too. I hope you can see what I'm trying to show you. Maybe I should put it somewhere. That means we have 8x squared minus 12b s cubed. So if we are factorizing out 4x squared, so it means 4x squared is dividing this, and the 4x squared is also dividing this too. So by this, what do we have? 4 here, 2 x squared cancel x squared. So that means we are left with 2a. Same thing happen here. 4 here, 3, and x squared in x3. That will give us x. So that's why we are left with 3 minus 3bx. Okay? So it's as simple as that. Now the second one is, of course, you're familiar with this. What you're applying here, it's what you call difference of two squares. When you have two numbers that are different, meaning you have something minus something. Yes. You know, in mathematics, what we're simply looking for is a known procedure that is applicable, okay, that we can use to solve what we are trying to solve. And from what you have here, you have a square minus b square, okay, equals to a plus b, a minus b. We call this difference of two squares. Okay, so but before we can apply difference of two squares, you have to make our value look like something that has two squares that are different of each other. Okay, that's what I mean. Okay, so from what you have here, you agree with me that you have x squared minus 7 squared. Okay, so if you have it in that way, you can conveniently apply this. So where our x square, x is our a, and our 7 is the b, as far as the expression is concerned. So from what you have there, applying difference of 2 square, we can simply write that x plus 7 and x minus 7. That's your final answer. It's as simple as that. So let's take a look at the rest. If you look at this one, of course, uh, it's not all the time that you factorize first. It's not all the time that you use difference of 2 squares first. It depends on the outlook, the way your question comes. Okay, looking at this expression we have here, if you look at it very well, you will want to use a difference of 2 square, but you cannot apply it straight up. But then again, if you look at it, you can still factorize. So then we go ahead and factorize. Do you know the common factor there, the highest common factor there? Are you thinking? Yes, it's 3. Okay, so we factorize 3 out. When we factorize 3 out, oh, it's coming to shape. Now look at it again. If you now expand this, you have this. Okay, oh, it's looking like it. Don't forget, for you to apply the law of a difference of 2 square, to apply the expression, each of the term in the binomial must be squared. If one is squared, the other one is not squared, you cannot apply difference of 2 square. So both of it must be squared. So if you're going to be able to apply difference of 2 square, you must be able to arrange it such that at the end of the day, you can see 2 squared, 2 squared. So that means 2 different units squared. Okay? All right. So from what we have, you will agree with me that this 2 square m square can be written as 2m all squared. You don't agree with that? Yes, very, very correct. Of course, if you remember your law of indices, what law of indices says, let's say we have a 2m raised to power 4. It says that the 4 is for 2 and the 4 is for m as well. So you can say 2 raised to power 4 and m raised to power 4. Okay, so now it's like going in the reverse from here to here. So when you have the 2 squares to be the same, you can actually put them under a single umbrella of a single squared value, single unit squared value. Okay, so from what you have here, you can conveniently write this as this, where in this case your n is your a and your 2m is your b. Okay, so if you have it that way, you can say equals to 3 into n plus 2m n minus 2m. It's as simple as that. Now let's take a look at the fourth question. Now for the fourth question, you have something here very, very interesting. If you look at it very well, what we see here is raised to power 4, raised to power 4. And the only known simple element for the simplification is difference of 2 square. So you agree with me that we can write this as this. Yes, because by law of indices, that's a power multiplication law. We know that 2 times 2 will still give you 4 back. Okay, so if you look at it, we have a squared, squared, 2 squared. Meanwhile, this square inside, you take it as just a unit element, as though it's just your y, or as though this one The first one is just your x. Okay, so if you're applying that, applying difference of 2 square tells us that we're going to have a square plus b square, of course, bracket close, a square minus b square. Are we stopping here? You're looking at it, Abby? No, we won't stop because something can still be applied. If you look at it very well, this is another 2 squared. Okay, so if you're going to sort out this square, you can apply simply the difference of 2 squared again. So if you're going to do that, that means you have a square minus b square to give us a plus b, a minus b. Okay, so which we can simply leave our answer like that. Okay, so let's take a look at factorization of trinomials. Now, the word trinomial is talking about a 3-term expression. Yes, a trinomial that we can also call a quadratic expression. So when you have that, there are methods that we employ, and that method is what we want to quickly explore. Yes, so that you don't get stuck or get confused when you have to do that. Okay, so if you have to factorize this, the procedure is very simple. The first thing that we have to do is, number one, let's go through the procedure one by one. The first procedure tells us this is a question. We multiply the first term by the last term. Now, we look at it very well. You have your first term as 3h squared, and you have the last term as minus 4. So you multiply them together. If you're multiplying it together, they will give you minus 12h squared. Minus 12h squared. Now, what's the next procedure? List out all the products that equal the results in A. What are we talking about? Our result is minus 12h squared. So we want to check out all the products that will give us that value. So can you see? Can you see? Can you see? Okay. So what we are saying with this is the fact that if you multiply all of this together, 3h times minus 4h, it will give you minus 12h. Okay, minus 12h squared. Okay, minus h minus 3h times plus 4h will give you minus 12h squared. Minus 6h times 2h will give you minus 12h squared. 6h times minus 2h. See, when you're dealing with something like this, your sign, you have to be very careful. And h times minus 12h will still give you minus 12h squared. So, and the last but not the least. So, after you have gotten all those values, we have an objective for going through this route. The objective is this. We are trying to solve the question there. Meanwhile, for us to solve it, we need to split this guy, the middle term. We are splitting the middle term. Okay? So, all this methodology is to help us to be able to split the middle term. Don't forget what I said earlier. The first thing you are doing first is to multiply the first term and the last term. Okay? Whatever it gives you, you now start listing out what you will multiply together to give you that value, which is what we have done here. That's what we have done here. You're just doing this as rough work somewhere. The truth is, The more you solve question with factorization, the easier it becomes for you. Okay? So from where you are there, uh, you're simply going to, of course, after listing out all the products that equal the result in A, the next step is to change the multiplication to addition. Now check which of these, when they are added together, will give you that middle term. Don't forget what I said earlier. Our target is to actually split this middle term. Okay? So, and when I say the middle term, I mean minus 4h. So you now check which of this expression or which of this combination is it that when you add it together will give you the minus 4h that we have at the middle here. If you look at it very well, we have our value. This is our value. Okay? So what do? You split straight up. You split. You split the value. Okay, can you see that? So you split it. We have just used this term here to split it. So after splitting it, the next thing is to group. Don't forget what we said the other time. This our bracket is you don't have to put it there. Okay, me putting it there is just to make it glaring what we are grouping out to solve. Okay, so if you don't want to put it there, in fact, you don't actually need to put it there. It's just for the sake of explanation. And that's why I'm emphasizing that it's just a bracket, an imaginary bracket to group. It is not a bracket to multiply. Yes. Some people will put the bracket, you will start multiplying. So when you put real bracket, it shows that they are product of each other, whereas it's just for grouping sake. They're just creating boundary. Okay? So from what you have there, you can then conveniently factorize. Of course, you agree with me that for 3h squared minus 6h, the common factor is 3h, highest common factor. Okay, so which if you factorize that will lead to you having h minus 2. And for 2h and minus 4, the common factor is 2. Okay, so if 2 is the common factor, what do? You factorize it out with it. And if you look at it very well, the good thing about the factorization of a trinomial like this is these two values will come out naturally if you have done the right thing. It's only if you have made a mistake somewhere, that's where you might have issue. Okay, it will come out naturally. Okay, so by that, so we can conveniently say that our final answer is going to be 3h plus 2, and you just pick one of these, h minus 2. I want to believe that is clear enough. It's as simple as that. Now let's take a look at another question. Look at this. For instance, you have a 2x squared minus 4xy plus 2y squared. I will implore you to look for questions to factorize. Yes, even though I have some exercise at the end of the video, yes, for you to solve, but it might not be more. I mean, I'm not giving you plenty question on those ones. So please look for question from your text and from any way, past question where you can see questions that look like that. So you can easily solve it. Okay? So now we have to factorize 2x squared minus 4xy plus 2y squared. Okay? So if you're solving that, what do? The same procedure. Yes, it's the same procedure. The first step is we multiply the first term by the last term. Okay? The same procedure. We multiply the first term by the last term. If you multiply it by the last term, it will give you 4x squared y squared. So if you have 4x squared y squared as provided here, okay, then you go back to your table to list out all products that equal the result in A. So we have our result. So what are the things that you can, the number, the value you can multiply together that will give you 4x squared y squared? You will agree with me? Okay, let's see. We have this minus 2xy times minus 2xy. I know somebody is asking, why can't we just do 2y squared times 2x squared? The reason we can't do that is whatever we do, don't forget we have a target. We are trying to split the middle term, this middle term here. And you can see the middle term is in xy. So if you do it that way, you will not get this and you will get stuck. You won't be able to solve the question. Okay, so from what we have here, you agree with me that minus xy times minus 4xy will still give us 4x squared y squared. This minus xy is the same thing as saying minus 1xy. Okay, so that when you see it in that from another place, you won't be confused. So xy times 4xy. So it's the same thing as saying 1xy times 4xy. Okay, so that being said, we can conveniently, okay, take out our guy here. That's the multiplication. So let's now say we are adding them together. Okay, so if you're adding them together, what will the first one give us? It will give us plus 4x, Abby. We have to look for the option which, when added together, will give the middle term and replace the middle term by them. Okay, so this plus 4x, y? No. So if you had the second one, minus 4xy, yay! Okay, now let's still continue with the rest. So before somebody will say that we can have two values. No, you can't. You can only have one single set of values that will replace the middle term. So for what you have here, what do you have? You have 5xy. Okay, so if you have that as given, the next thing is for us to group and factorize the new expression. Okay, this is the new expression here. Okay, so we are grouping now. We are grouping now. You agree with me? Stay grouping, not bracket. Stay grouping, not bracket. Stay grouping, not bracket. Stay grouping, not bracket, not bracket. Okay, I'm saying that for sake of emphasis so that it rests on your subconsciousness that it's not bracket that is there. It's just grouping. What we are putting there, I call it imaginary bracket. Okay, so let's factorize. So what do we factorize at there? Are you looking at it? 2x squared minus 2xy. What are we factorizing out? Are you thinking? Oh, you've gotten it already. That's 2x. Very correct. 2x. Okay, so if it is 2x, that's you factorize that 2x from here, it gives you this. You have a minus 2xy plus 2y squared. Don't forget what I said before, that whenever you have a negative outside there, the last negative you have there, once you have a negative there, it's much safer. In most cases, not in all cases. Yes, depending on the way the question comes, you use the negative value to factorize. And you know when you're dividing through by a negative value, you also affect the sign. Negative changes everything. Negative changes everything. Negative changes everything. Okay, so from what we have there, so that means we can conveniently say minus 2y into x minus y. So you can see our two similar value come out naturally. So from what you have there, you can conveniently write this as this. Okay? Is this your final answer? Are you sure? Are you sure? If you stop here, this is not going to be a very correct answer because you have to factorize. You're expected to factorize completely. If you look at this guy here, something can still be factorized out. Something can be factorized out. So you do that. If you don't do that, your final answer will not be correct. Okay? So we factorize that. So you can see 2 can be factorized out. So this is going to be our final answer. It's as simple as that. Thank you. All right. So now let's take a look at one last question on factorization of trinomials. If you are asked to factorize this, don't forget what I said. A lot of times, factorization doesn't go straight. At times, it goes straight. So the one that you have been applying the other multiplying the first term by the last term too. If you check it very well, in most cases, it's either they have the same power. And for this case, you can see you have y cubed there. So what do we do first? So like I said, just have an open mind. Apply what is applicable. It's not all the time that what you want to apply might be needed. You just have to check for the relevance of the procedure you are trying to apply. Okay, so what's the first procedure here? The first procedure is to simplify by factorization. So if you look at it very well, y and 4 are common in all. Yes, that's the highest common factor in everything. So you factorize out 4y. So if you're factorizing out 4y, it reduces everything into that form. So what's the next step? From the resulting quadratic expression in the bracket, multiply the first term by the last term. Meaning that we are referring to this guy in the bracket, this guy in the bracket. Yes, this is the expression that they are talking about. Talking about this expression. Okay, so we are doing the needful as usual. Okay, so we multiply the two values. So if you multiply it, it gives you 10x squared y squared. Okay, so as usual, let's go to our board to sort it out. Okay, two values that will give us that our 10x squared y squared. Yes, 2xy times 5xy. Don't forget again why we are picking xy and not 2x squared times 5xy squared is because our target is to have something of the form of the middle value, the middle term in the quadratic expression, in the trinomial. Okay, so from what we can conveniently pick another value, minus 2xy times minus 5xy. That one too is an option. We have another one, minus xy, don't forget minus 1xy or minus xy times minus 10xy. Okay, and the last but not the least, xy times 10xy. Okay, so if you have that, you can conveniently, okay, then check which of them is it when added together will give you our middle value here. Our middle value, that's our middle value. That's our middle value. Okay, so which one will give us our middle value as stated? So let's start by adding. So the first one, you have 7xy is equal to our middle value? No. The second one, minus 7xy? No. The third one, minus 11xy. Yes. Okay. And the last one, 11xy. Of course, no. So I'm trying to use this to emphasize the fact that it will only be one pair. No two pair will be able to fill in that space. Only one. And it is your responsibility to find that one. Okay. So from what we have here, you will agree with me that we can go ahead with the splitting. You can split. Okay. So that means we have successfully splitted this into this. Can you see that? That's what we splitted into that. It's the same thing, no harm done. We're just trying to solve. Okay. And also, if I've not mentioned it before, factorization a lot of time can be taken as the reverse procedure or reverse process to expansion. Okay, factorization is a reverse of a expansion. So we're trying to get what we will have had, yes, which when we expand it, it will give us this value back. Yes, that's the implication of our factorization. So from what we have here, you agree with me? The next thing is our usual grouping. You can see the state group. So a grouping, you factorize. Okay, so if you factorize this, you have a y into 2y minus x, a minus 5x into 2y minus x. Okay, so from what you have there, you can, of course, you know the procedure, which is we're picking one of these, and also we're picking y minus 5x, which is what you have here. Okay, so if you put that there, what does it give you? It gives you our final answer. So it's as simple as that. If you have any question, you can ask in the comments section. And when you are quoting a question, make sure you put proper reference, the example number it is, if possible, the time. Yes, that it is. Okay, so it's very, very important. All right, so let's progress into simplifying algebraic fraction. Algebraic fraction. Algebraic fraction. Let's simplify the following. You will understand or you will appreciate better all we have been doing with factorization that we've been playing about. Yes, with what we're about to do now. Solution: a minus b over b squared minus a squared. So if you look at it very well, what do you see? You see difference of two squared. Okay, so we are applying difference of two squared here. Okay, so if you apply difference of two square, it gives you that. Can you see that? Hmm? Can you see it? Hmm? Difference of two square. That's what will give you that. So you can see very well. Uh, Normally, the reason why we do this is so that it will aid the simplification process. But if you look at this guy very well, Hmm. nothing is still simplifiable. So this a minus b and this b minus a, they are not the same thing. So we want to rewrite this guy in a way that will help us to be able to factorize. So you agree with me. If I bring minus outside, factorize out minus 1 or just minus, either way you call it, you're still going to be correct. You agree with me that minus times minus here will give you the plus a back. Minus times plus b will give you minus b back, Abi. Okay, so you also agree with me that I can now rewrite this as b minus a. It's the same thing as minus a plus b. It's still the same thing. So at this point, we can easily cut this. So what do we have as our final answer? Minus 1 over B plus A. It's as simple as that. Do you have any question on that? Okay. If you have any question, you can ask in the comment section. Okay. All right. Thank you. So let's take a look at the next example. We have another very interesting question here. Simplify. Oh my God. Very beautiful question. Okay. So taking a look at this, uh, you can see that's many parts. When you have a question like this, of course, the first thing you do, because it's just division and multiplication. Yes, translate your division sign to multiplication. And you know the rule, when you are translating it to multiplication, you flip, okay? So that flipping will occur from here to here. You can see this has come down and this has gone up because of the flipping, the conversion of a division sign to multiplication. Okay, so from what you have there, you agree with me that the next thing to do when you look at your question very well is to factorize. Factorize. So you factorize all of the expression. Yes, it doesn't look like anything, but when you factorize everything, it will bring out what you need and something that can help your simplification process. Okay, so if you check very well, you see we have a x into x plus y, 4 into x plus y, x into y minus x. And the same thing goes for the denominator. If you factorize this, you can factorize it somewhere, of course, uh, using the methodology that we have used not too long ago. Okay, and this one, the same thing goes for it. So it all depends on the way your question comes. The question can come in this form, and you will need to factorize. So if you factorize everything, you have that as your answer. So if you're now solving further, of course, before you get to this place, you agree with me that x plus 1 cancel x plus 1 here, and then x plus y cancel x plus y. Okay? So what do we have left? X4. That's how we come about this. And if you look at this very well, this is having something similar to what we had before. Because you have to just be observant. Don't just cut. Y minus x is not the same thing as x minus y. So you have to translate this y minus x to a form that will permit you to be able to do any form of division at all. So you agree with me that we can write this as this. Okay? Hmm? So it's still the same thing. We factorize out negative, and of course, that will make this one minus y plus x, which will give us this. Which if you solve further, of course, by this, it means x minus y cancel x minus y. Okay? So 2, here 1, 2 here 2. So by that, you can multiply all what is left at the numerator and all what is left at the denominator. Okay, so that means we have this. Is there any other thing we can do? Always leave your value, especially the denominator, factorize. It's very, very important. So, in the absence of nothing else, is going to be our final answer. Okay, very good. So now let's take a look at something quickly. Uh, Still on a algebraic fraction. If you ask to simplify the following, you say easy peasy, right? Good. So from what you have here, you are simplifying, okay? As usual, what you do is to find the LCM of the denominators, okay? So what's the LCM of the denominator in this case? Of course, it's going to be, because they are not regular values and they are not looking like something that is a factor of the other. So the safest way, I mean, one of the easiest way to sort this out is just to multiply the two together. Okay, so that means our LCM will be this. Okay, that's s plus 1 times s minus 2. Okay, we are not expected to expand it. Don't forget, when you have it in your at the denominator, you don't just expand it. So s plus 1, s minus 1 divided by s plus 1, that will give you x minus 2. Okay, so s minus 2 times 3, what will it give you? That's 3 into x minus 2, which is that. Can you see that? Okay, so the same thing you do again. S plus 2, I mean s plus 1, x minus 2 divided by x minus 2. That will give you s plus 1. So then, don't forget this sign of minus 1. Minus 1 times the resulting value, which is x plus 1 minus 1 times s plus 1. So what does that give you? You expand. If you expand, then you collect like times. If you collect like times, of course, you have that. And if you solve it further, you have 2x minus 7 over that final answer there. And for B, the same procedure. It's only that you also have a binomial at the numerator there, but the solving is as easy as it comes. So from what you have there, you agree with me that our SM is what we say fine, okay, which is t plus 3 and t plus 2, which you're going to, of course, t plus 3, t plus 2 divided by t plus 3. So we are left with this alone. So this multiplying this. So that's how we come about this. Okay. So minus, okay, the same procedure, this divided by this. That's t plus 2. Of course, it will cancel out this and you're left with this. So that's t plus 3 times t minus 2. So which is going to give you t minus 2, t plus 3. So from there, you can then expand further. If you expand it further, what do you have? Of course, uh, you have the resulting trinomial. Don't forget, don't touch the denominator. Don't touch the denominator. Okay? So from what you have there, of course, the minus changes everything. Minus changes everything. Minus changes everything. So you multiply this other value by the minus. Okay? So of course, you can see how it changed everything. So the next thing is to collect like times. So if you collect your like times, it will give you the resulting value. Because by this, t squared minus t squared is 0, minus t, that's minus 2t, minus 6 plus 6, that's going to be 0 too. So that means this is going to be our final answer. If there is nothing else that can be factorized out again, you leave it like that. Please don't cut 2 by 2. Very, very wrong. Okay? It's very, very important to take note of that. So, like I said earlier, if you have any question, don't forget to ask in the comment section. But try and go over the video again. If it's not clear at first, I believe you come across a word that will make it clearer as you progress. Okay? So, the last but not the least part of this topic is undefined or zero fraction. Undefined or zero fraction. Okay? This is what we mean. If you can try it with your calculator. If you say 6, let's say you say 6 divided by 0, you can punch it on your calculator In most cases, it will show an error. Yeah, it will show an error message. So it's because it has been discovered over time that division by 0 is not continuous. It's not continuous, meaning that it's undefined. Yes, it lacks continuity. It doesn't have expression. It doesn't have anything that characterizes it in terms of value. So it is undefined. So also you can check with your calculator 0 divided by 6. Okay, so anything divided by 0 is undefined, and anything I'll say that again. Anything that is 0 divided is undefined. Undefined. And anything you use to divide 0 will give you 0. Okay? So now we are using this reality to solve this. We say, for what value of x does the fraction 3x minus 6 over 2x plus 5 becomes undefined? So the only time it becomes undefined is when the denominator is 0. Okay? So for this to become undefined, we say we have the denominator becoming 0. It implies that the denominator becomes 0. The denominator becomes 0. Okay? So with that, you can get your respective value of x. So your answer is 2 number 1 over 2. Don't forget, you don't leave your answer as improper fraction. Okay? So now, for the other part, another what we call equal 0 is that it vanishes. Vanishes. 0 and undefined, they are not the same thing. The 0 is not nothing. Okay? Alright, so when it's equal to 0, from what I've said, that's when your numerator is equal to 0. Okay? And what's our numerator is in this case, what's our numerator? That's 3x minus 6. Okay? That's when it's equal to 0. That's when the expression, the fraction, become 0 or vanish. Okay? So with that, we have our answer, x equals to 2. Okay? This is where we're going to be putting a stop to our journey here. Yeah, this is your assignment. Okay? So you're expected to copy it and solve. Please, if there's any part of this video that is still not clear, go over the video again and again. You can also drop question in the comment section. Anybody that can explain, somebody might be able to help you out. Okay? Any question, and as much as possible, I will respond. Okay? So thank you for your patience. It's a long one. If you're not able to listen to it once, try and listen to it in fragments. You will definitely gain 1 or 2 things from it. Thank you.